Imagine if everything around you, your phone, your chair, even you, were built from tiny, invisible Lego blocks. Welcome to the world of atoms, the universe's smallest building blocks. Let's dive into their structure, meet their subatomic particles, and discover why they're the foundation of all matter. Let's take a moment to explore today's objectives. By the end of this video, you'll be able to understand what atoms are and how they're structured. Identify and label the main parts of an atom. Compare the properties of protons, neutrons, and electrons. So first things first, what is an atom? The word atom comes from the Greek atomos, meaning indivisible. Ancient thinkers thought atoms were the smallest possible particles. But today, we know atoms are made of even smaller parts: protons, neutrons, and electrons. Now let's shift our focus to the modern definition of an atom. So what is an atom? An atom is the smallest particle of an element that retains its chemical properties. For example, a gold atom is the tiniest piece of gold you can have. Let's take a closer look at what atoms are made of. Atoms have three main parts, and each one plays an important role in how atoms behave. First, we have the nucleus, the dense core at the center of the atom. It's where you'll find protons and neutrons packed tightly together. Electrons, tiny negatively charged particles, move around the nucleus in areas called shells or energy levels, kind of like how planets orbit the sun. But before we continue, here's an important key fact. The nucleus holds 99.9% of the atom's mass, but is tiny, like a marble in a football stadium. Let's refocus on the structure of an atom. At the center of the atom is the nucleus, which contains protons and neutrons. Protons carry a positive charge. Neutrons have no charge. They are neutral. Surrounding the nucleus are the electron shells, often shown as blue rings. These shells hold electrons, which have a negative charge. So, in summary, protons are positive, neutrons are neutral, and electrons are negative. Let's go through some examples. We will be learning how to draw a carbon atom. Draw a nucleus, small circle in the center. Inside this circle includes 6 protons and 6 neutrons. Label it nucleus. Draw 2 rings around the nucleus. Label them first shell and second shell. Add 2 electrons on the first shell and 4 electrons on the second shell. Now, this is a carbon atom. Let's go over the shell rules. The first shell, closest to the nucleus, can hold up to 2 electrons. The second shell can hold up to 8 electrons. In short, atoms start with the first shell. If they have more than 2 electrons, they use the second shell. If they have more than 8 electrons, they need the third shell. Not all atoms have a third shell. Only the larger ones, like sodium, which has 2 electrons in its first shell, 8 in its second shell, and just 1 electron in its third valence shell. Let's take a quick drawing break. Now it's your turn. Pause the video or put your pencil to paper and draw a boron atom using what we just learned. Draw the nucleus with 5 protons and 5 neutrons. Add 2 shells. Place 2 electrons on the first shell. Put 3 electrons on the second shell. Label it boron atom. Ready? Pause now and give it a go. We'll check it together in just a moment. Well done. Here's the boron atom structure. Let's talk about the properties of subatomic particles. We'll start with the proton. Now listen closely. Protons are super important because they help define what an element is. Charge. A proton carries a positive charge. We say +1. Mass. It has a mass of about 1 atomic mass unit, or AMU for short. Location. You'll find protons right at the heart of the atom in the nucleus. Next up is the neutron. Think of this as the proton's neutral buddy. Charge. Neutrons have no charge at all. They're neutral. Mass. Just like protons, they have a mass of about 1 atomic mass unit. Location: they also live in the nucleus right next to the protons. Now for the electron, the smallest and speediest of the three. Charge: electrons have a negative charge written as -1. Mass: here's the crazy part. Their mass is tiny, about 1/8400th. That means they're nearly 2,000 times lighter than protons or neutrons. We usually say their mass is so small it's negligible when calculating the atom's total mass. Location: unlike protons and neutrons, electrons don't hang out in the nucleus. Instead, they move around it in specific zones called electron shells or orbitals. Why does any of this actually matter? Great question. Understanding these tiny particles helps us make sense of how atoms behave and even what element we're dealing with. Let me break it down into 3 simple reasons. Atomic number. The atomic number is just the number of protons in an atom. And guess what? That number tells us exactly what element it is. For example, carbon has 6 protons, so its atomic number is 6. Change the number of protons and you get a completely different element. Mass number. The mass number is the total of protons plus neutrons. So, if we look at an atom of carbon-14, it has 6 protons and 8 neutrons, which gives us a mass number of 14. It's like the weight class of the atom. Isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. So even though they're the same element, they have different masses. Carbon-12 has 6 neutrons. Carbon-14 has 8 neutrons. They're both still carbon, but they have different masses. Here are your key takeaways from today's topic. Protons define the element, neutrons stabilize the nucleus, and electrons drive chemistry. Atomic number equals number of proton, and mass number equals protons plus neutrons. Atoms are mostly empty space, yet they make up everything we see. Next time you sip water or charge your phone, remember, trillions of atoms are working together in perfect harmony. Stay curious, because every atom has a story to tell. Hello, learners. Feel free to drop by and visit our website for more free resources, worksheets, and tuitions. Visit us at www.anselhillacademy.co.uk today to get started, and subscribe for more updates, tips, and learning materials.